In this video, we are looking at the calculus of motion. So some theory on the calculus of motion. So S of t, so S meaning distance, okay? So this is like physical science somewhat. And so St represents an equation of motion, the height, the distance, the displacements at a certain time. So S prime t, once we do a derivative of S of t, this means S prime t now goes one step up, and that becomes the velocity or the speed at a certain time. Alright? So velocity and speed means more or less the same thing. And then S derivative, so in other words, do a derivative twice, t represents the acceleration at a certain time. So the first one, St, is the distance or the height, okay? S prime t now becomes the velocity. A second derivative is now the acceleration. And so in the previous video we did something called the points of inflection. So it's like the same thing. F prime t, that will be the first one, right? And if we do a derivative again, this now becomes the point of inflection. Okay, so it's practically the same thing, okay? So here they say, consider the following situation. An object is moving from its position at 0 to A and then back to C. So it moves from from 0 to A and from A back to C. And so that means it'll cover a certain distance over time, which would be velocity. And when a certain velocity is covered over a certain time, it then becomes acceleration. Okay. If an object moves from 0 to A, we say that its displacement from 0 is 6 units. Okay, does that make sense? Let's go back to the diagram. 1, 2, 3, 4, 5, 6. If the object moves from 0 to A, we say the distance is 6 units. If the object now moves in the opposite direction to point C, we say that its displacement is from A to C and is only a negative 4 units. The object's displacement from position O after moving from O to A and then to C is 6 plus 4 is equal to 2 units. So the object's displacement is only 6 minus 4 because it's in the opposite direction, and so in effect it only moved 2 units. Okay, that is displacement. So displacement is like the distance from start to end point. Your starting point to your end point, what is the straight line distance between those two? The total distance moved from A to C, right, via A. So the total distance after moving from O to A to C is 10 units. Distance is always positive because as it takes the whole direction, whole distance traveled into consideration. Displacement does take the direction into consideration and can be positive or negative. Velocity is speed in a given direction. If the object moves in one direction, say from left to right, from B to A, we can define its velocity to be positive. If it moves in the opposite direction from A to B, the velocity would then be negative. So speed of the object is independent of the direction of movement. So in other words, speed is like distance over time taken. Alright, but velocity takes into consideration the start and end points only. Alright, but notice here in our questions the displacement is going to be the distance, okay, in most of the calculations. So it's not going to be something that is too difficult to do. Okay, do stay with us and let's see if we can tackle some questions. Right, so these questions are not difficult at all. When you see it being word problems, the mind will normally say, this is too difficult for me. No, it's not difficult at all. Okay, so A person must have a level of confidence before approaching something and must believe that they're able to conquer. Alright? An object moves from its starting position at point 0, and its motion is described by the equation S of t is equal to 20t minus 2t squared, where S represents displacement in meters and t the time in seconds. Okay, so S represents what? The distance or the displacement in meters, and t is the time. So this means if I substitute t for the seconds, I'm going to get the answer, which is going to be the displacement. The first question, the displacement, in other words the distance of the object after 1 second. Let's go back, where S represents the displacement, S is displacement, t the time. So if I substitute time, what will I get out as an answer? Displacement. That's how easy that is. And so in exams, that will be 2 marks just to substitute the t and get an answer. So please, man, this stuff is very simple. Okay, so this is what was given. S of t is equal to 20t minus 2t squared. In the first question A, it said that the time was just 1 second. This means I need to substitute 1 second. Substituting t as 1 and getting our final answer. And so 20 subtract 2 is 18 meters. The second question B says the time taken to reach maximum displacement for the given interval. So notice it uses that word maximum, and that's a key indicator. So maximum means the maximum turning point. Now how do we find turning points like the cubic function or in the parabola? How do we do that? We do a derivative of the original question and then let that equal to 0 and solve for t. So that means S prime t is equal to, looking at the original question, 20t will become 20. It will drop the t. And then minus 4t, because minus 2 times 2 is minus 4. 2 minus 1 on the exponent will give us 1. So that is minus 4t to the power 1. We don't write the 1. Does that make sense? Then we're going to let all of that equal to 0 and solve for t. A negative 4t on the right hand side moved to the left hand side will become positive 4t. All of that 4t is equal to 20. Then we solve for t. Dividing both sides by 4, t is equal to 5 seconds. T's question says calculate the maximum displacement. So the maximum displacement will be the height up to the turning point. Okay, so if something's thrown up, that will be the maximum height that will reach. So remember that cubic function, we have maximum and minimum turning points. Okay, and so with the parabola, we only have one turning point, and here it's always going to be a maximum because the object is thrown up. Okay, now notice, for us to get the turning points, we have to substitute the time that was taken, in other words the x value, to get the y value, because that's the same on a Cartesian plane. If we look at the Cartesian plane in orange, notice that that distance moved will be the x value. So they're telling you here that the x value has now become the t value, and so the time is now 5 seconds. If I substitute x into the original question, I will automatically get the y value. So I can determine the y value by substituting in that 5. You with me? So in other words, that will now become the st, which is the distance. So the turning point is actually 5 for x and 50 for y. But remember, they just want the distance. So the height will be 50. Okay, just refreshing our memory what we wrote in our books. I didn't mention this yet in the video properly. So st is the position, okay? In other words, it's the distance above the ground, st. Vt is the velocity, but we get the velocity by doing a derivative on st, therefore s prime t. Acceleration is the velocity, the derivative of the velocity. Okay, in other words, it's s prime prime t. So if you do a derivative twice on st, you will now get acceleration. If you do the derivative after you have the answer of f s prime t and you do a derivative again, you will then get the acceleration. I hope this makes sense. Notice that velocity is equal to the speed. Okay, as we continue, do go back to the beginning of the video and watch that again, and watch it a second time. I think after 2 times you should get it. So these questions here is the time taken to reach a displacement of 32 meters from 0. So you agree at the center point there where the Parker pen is, that will be 0. And so they're saying that you'll be 32 meters above the ground. So they want you to find out what will be the times taken, question D. Now I want you to remember that y is equal to st. So where st is, we're going to substitute 32 and then solve for t. Okay, it's simple because they're telling you that st is 32. So where st is, substitute 32 and manipulate it, bring it into standard form and solve for t. So plus 32 will become minus 32. Put it into negative t squared first, plus 20t minus 32. So taking out a common factor of minus 2 or dividing every term by minus 2 as shown, you will get this. Okay, notice that it now becomes a positive t. So we are saying every term you see there divided by minus 2 or remove a common factor of minus 2. And so now you're going to factorize that using simple factorization. There's no need for the quadratic formula here. Find the factors of 16 and get the 2 brackets, 0 factor rule. Come on, you can do it. Pause the video, try it out. Now the factors of 16 are 16 times 1, but that won't give us 10, and we have 8 times 2. 8 times 2 can give us 10. So let's use 8 and 2, but work it with a combination whereby when adding them up, you will get a negative 10. Think about it. Now the positive in front of the 16 means that the signs must be the same, and so therefore they're both going to be negative, so that we can get minus 10. Minus 8, minus 2 are our numbers that go in the bracket. And so this is why it's important to study the 0 factor rule, which many children can't get right. You have to know how to do that because every question boils down to that. After you factorize and you have to solve for x or t or whatever the case. Right, so letting each bracket equal to 0, solve for t. And so there we have it. T is equal to 8 and t is equal to 2. Does that make sense? Go back to the graph and see if that makes some sense. On the left side you'll have a small number, and the right hand side you'll have a big number. Okay, so t equals 2 and 8. So our diagram would now look something like that. Notice that at 32, that will be it there. Right, so notice 2 and 8 were our numbers. And then, if you were to take those two x values and divide it by 2, what would you get? So that'll be 10 divided by 2 will give us 5 seconds. Do note earlier up, our time was 5 seconds. And if I take that 5 seconds and put it into the original equation, guess what? I'm going to get the turning point. It's as simple as that. And you're going to get the same answer. Now each question is kind of like to prove the case. They say calculate the distance after 2 seconds, where we're going to substitute that into the original question. So the distance after 2 seconds, we substitute 2 and then we're going to get the answer. The answer there is going to be 32 meters. And then I want you to put in 8 seconds and see what distance you're going to get then. So do note that the distance above the ground at both 2 and 8 seconds is going to be 32 meters. Does that make sense? Now the next question says the time taken, right? That means you're going to have to calculate t to reach 0 meters above the ground. Okay, so substitute 0 for the distance and then move everything over to the left hand side so that it can become positive. So moving them all over to the left hand side, minus t squared will become positive 2t squared. Okay, you get it, so move it over, right? And then take out 2 as a common factor. In other words, divide everything by 2. Then remove t as a common factor. Do you note the zero factor rule again? So the t on the outside would be equal to 0, and t minus 10 would be equal to 0. Moving 10 to the other side, t is equal to 10. So this means the object is thrown up. At time 0, it didn't travel at all, this object that was thrown up. Okay, so at time 0, its distance covered was 0. It goes all the way to a maximum, but then falls and hits the ground 10 seconds later. What's its distance? 0. We substituted 0 to find out what were the times when the object was at 0 distance above the ground. We're going to leave 2 questions out and we're going straight to I. So bear in mind we're teaching this for tech math, right? So initial velocity t is equal to 0. So the question says in I, calculate the initial velocity. They're telling you in brackets t is equal to 0. In the exams they won't tell you that t is equal to 0. You must know initial velocity, substitute t is equal to 0. Now with initial velocity, don't forget we must, st is distance or displacement and s prime t is velocity, which means we'll have to do a derivative first. And then for initial velocities we substitute 0 for the time. And so 20 minus 4 times 0, 4 times 0 is going to be 0, so the answer is 20. Then J's question, the velocity and speed at 1 second. So we'll substitute 1 into the derivative, right, the one that was derived. So looking at the original there, the derivative was 20 minus 4t, right? And then we're going to plug in 1 second there, and we're going to get an answer of 16. Case question says, Case question, the time taken to reach a velocity of 4 meters per second. The time taken, this means we're going to need to find t. So we're solving for t. This means s prime t is the velocity, and the velocity here in k is told to be 4 meters per second. So where will you substitute the 4? By s prime t. So taking over the negative 4t, it will become positive 4t on the left hand side, and taking over the 4 to the right hand side, it will become minus 4. And so now we get time is equal to 4 seconds. Time is equal to 4 seconds. Now looking at the speeds, the initial velocity, so in other words 0 seconds, was 20 meters per second, calculated in I. 1 second later, calculated at J, 16 meters per second. 4 seconds, it was 4 meters per second. Okay, calculated in K. And that's how easy it is. We're just going to do one more to get the idea. Let's do L. Okay, let's do L. L says calculate the velocity at 5 seconds. So all we have to do is substitute 5 into 20 minus 40. What will we get there? And so we get 0 seconds. 0 meters per second. Okay, this means the item came to a stop. Okay, at 5 seconds. At 5 seconds later, it came to a stop. Right, and that's how we do that. Very simple.